How Electricity and Magnetism Will Impact Our Future by Kyle Geary. So I'd first like to start off by looking at Tesla because I feel like he plays a very pivotal role in the implementation of electricity and such things as waveforms with radio implementations and other physics concepts he brought really out in the open into the nature of for more entrepreneurs and inventors to look at. So Tesla was born in 1856, died in 1943. He was a mechanical and electrical engineer. Was maybe the most prolific inventor ever. Tesla is often described as the most important scientist and inventor of the modern age. He's best known for his revolutionary contributions and inventions in the field of electricity and magnetism in the late 19th and 20th centuries. Tesla's patents and theoretical work form the basis of modern alternating current, otherwise known as AC systems, such things as AC motors, things of that nature, which he helped usher in the second industrial revolution. After his demonstration of the radio in 1894, and being the victor in this war of currents that was going on between him, Westinghouse, and Edison on different theoretical theories of current and electricity with DC and AC electric power distributions. He was widely respected as the greatest electrical engineers who worked in America. Much of his early work pioneered modern electrical engineering, and many of his discoveries were of groundbreaking importance. Such from his work on electromagnetism and electrical mechanical engineering, Tesla has contributed in varying degrees, such as robotics, remote control, radar, and computer science. Also expansion of ballistics, nuclear physics, theoretical physics as well. Many interpret the 1943 Supreme Court of the United States decision as crediting Tesla as being the inventor of the radio. To support some of his theories were kind of controversial, like UFOs and early New Age implementation theories as well. Also, a couple little fun facts about Nikola Tesla. It's said he was born during a lightning storm, which I find kind of funny. Some say that he developed the idea of smartphone technology. He's also said to have a photographic memory. It was basically a germaphobe. Let's now get into electricity and magnetism. Definition factory for the physics concepts. Electricity is a form of energy that's transmitted through copper conductive wire to give power to the operation of electrical machines and devices such as industrial, commercial, institutional, and residential lighting, electric motors, electrical transformers, communication networks, home appliances, electronics, etc. That's just kind of the basis for what electricity is used in, if you really just plain simple terms to put it. We use electricity with almost everything. Magnetism is a type of attractive and repulsive force that acts up to a certain distance. The distance up to which this attraction and repulsion force acts is called a magnetic field. Magnetism is caused by the moving electric charges or electrons. When two magnet materials are placed close to each other, they experience an attractive or repulsive force. In 1820, Hans Christian Ørsted observed a surprising thing, which he switched on the battery from which the electric current is flowing. The compass needle moved away from the point north. After this experience, he concluded that the electric current flowing through the wire produces a magnetic field. This is how the combination of electricity and magnetism flow together. Like electricity and magnetism are closely related due to this. The electric current flowing through the wire produces a circular magnetic field. Electricity basically creates this magnetic field due to the current in conductive wires, especially inside such things as motors, and you create this flux field. The direction, clockwise or counterclockwise, of this magnetic field depends on the direction of the electric current. So this is reference to the electricity and magnetism. So let's look a little deeper at the electrical concept, electricity, with another element of static electricity. It's stated to be a familiar electric phenomenon in which charged particles are transferred from one body to another. For example, if two objects are rubbed together, especially if the objects are insulated and the surrounding area is dry, the objects acquire equal and opposite charges, and an attractive force develops between them. The object that loses electrons becomes positively charged and the other becomes negatively charged. The force is simply the attraction between charges of opposite sign. The properties of this force were described above. They are incorporated with the mathematical relationship known as the Coulomb's law. The electric charge or electric force on a charge Q1 under these conditions due to charge Q2 at a distance r given by Coulomb's law. F equals your K, your constant Q1 times Q2 divided by the r or distance squared. So let's look at the magnetism concept a little in depth and deeper here. Magnetism is a force of attraction or repulsion that acts as a distance. It's due to a magnetic field which is caused by moving electrically charged particles. It is also inherent in magnetic objects such as a magnet. Hence the word magnet, magnetism. A magnet is an object that exhibits a strong magnetic field and will attract materials like iron to it. Magnets have two poles called the north and south pole. These two magnets are attracted by their opposite poles and each will repel the like pole of their magnet. Magnetism has many uses in modern life. This is very generic, and obviously we all know about north and south poles and magnets and how they act and attract and repulse. We understand that. I think one thing I found kind of useful with what I'm going into is engineering, and within certain cylinders, air cylinders, for example, inside of an industrial environment, we use air cylinders to eject parts or push something away. For example, inside that cylinder, the bore, the diameters of those pistons that move up and down are magnetized, and so you can take little particles like these irons, it's iron here, and put it on that, and you can watch as you pull the cylinder in or out. You can see the iron little pieces going with it to see that magnetic field acting upon it. The thing that makes this interesting, especially with the electrical component of that, is that we can connect these things called reed switches onto the cylinder, which tells you where the position of that cylinder is. Is it retracted or extended? How that works is together combined electrically and magnetically. The reed switch is a magnet as well, which is based, if it's closed, that the bottom reed switch would come on based on the electrical wiring that you did to combine all this together. So that's an example of magnetism and electricity forming together to accomplish a goal per se in the certain line of work I do. So we've been talking about the magnetic field. This consists of imaginary lines or this flux coming from moving or spinning electrically charged particles. Examples include the spin of a proton and the motion of electrons through a wire and an electrical circuit. Different things like circuit board, anything that's electrically wired up creates this certain amount of flux inside of it for a magnetic field. It actually consists of can be somewhat of a mystery, but we do know it is a special property of space, this magnetic field. We can't actually see this with our own eye, just looking at it at a glance, but that magnetic field is there. And if you can envision, this sort of field happening, so as we're talking about this field, we can kind of see it here coming into the demonstration with this picture and the flux flow from one end of an object to another. We call one end of the magnetic object the North Pole and the South Pole, related to the Earth. If we kind of look at this ball here as the Earth, if we see the North and the South Pole as it is, and you can see this arbitrary flux lines and field that comes out of it, it's moving from the North and South poles. As you can see, it comes from the North, as it repels away to the South. This is where you see the opposite and like particles repel and opposites attract together. Another important thing to add upon this, we're talking about with these fields and the flux lines on these diagrams and graphs, or pictures rather, we're saying this creates a magnetic force. This is with the magnetic field. This is what you call the magnetism. When a magnetic field is applied to a moving electric charge, such as a moving proton or electrical current in a wire, force on the chart is called Lorentz force, denoted by Lorentz himself. So to kind of, I guess, sum it all up, magnetism, just a generic basic definition of these is that magnetism is a force that acts as a distance and is caused by a magnetic field. The magnetic force strongly attracts an opposite pole of another magnet and repels a like pole. So we've kept talking about how the electrical charge and magnetisms are closely related and how they work together to accomplish goals, such as that example I gave with an air cylinder, pneumatic cylinder. A magnetic field is a dipole field, so it means that every magnet must have two poles. It must have a north and a south. On the other hand, when you're looking at electricity and the electrical charges, it's positive or negative electrical charge, and that can stand alone. Electric charges are called monopoles, since they can exist without the opposite charge. With the magnetic field, you need an attraction and opposite charge with it. With the electrical charges, it can exist without the opposite charge. So you could have this positive voltage, for example, without a negative voltage. So I'd like to look at future usage. To me, an example that has really hit home with something with my line of engineering degree that I'm going into in the fields that I've worked in so far. And I apologize for how small this is. I wanted to make sure I could get this all fit on one slide and it comes straight out of my paper, but basically I'm just going to explain kind of where I see this magnetism and electrical being put forth with the future, and the best way I can see it being used is with the transportation system. I think if we look at that through a human eye, when you're looking at the roads, if you look out your window and you see the road, it's on a 2D, you see that as a 2D plane. You don't see a road as in the human eye on a 3D plane, an X, Y, and Z axis. All you see is your X and Y. You see this flat plane or vertical plane, however way you're looking at it. Something Elon Musk, if people haven't heard or haven't looked at, he's working on now is, so with that being said, our current transportation system's on a 2D plane. How can we elevate that and achieve a better efficiency for transportation? Well, we can make it into a 3D plane. So what's the two ways of doing that? Is you can either go up, so to the sky, or you can go down, you can go underground. So what Elon Musk is doing right now is he's starting up a company to build and dig underground tunnels for this new transportation system, which the cars, where this falls into the concepts we're talking about here with electricity and magnetism. The cars would be on an elevated plane with magnets pulling the cars as they're going. It would be on a magnetic surface to keep the cars attracted or attached to this railway, and they're going to go at high speeds. So this would be used to keep, make sure nothing bad would happen within the tunnels themselves. I thought that was interesting concept to bring to the future, and I could definitely see that being the next big step in everyday society use that we're doing is something with the transportation system. We see so many traffic jams and so many stoppages within the traffics and wrecks and fatalities just with the transportation system, especially in America as it is. So I could definitely see this being the next big thing that impacts our future.